You see oxygen enrichment in your daily targets. Oxygen percentage set point 27.5%. But do you really know what that oxygen is doing inside the furnace? Most operators think more oxygen is equal to more production. Yes, but that's like saying more gas pedal is equal to faster car without understanding the engine. The real magic happens at the raft, that cohesive zone of semi-molten ore and coke hovering above the tuyeres. So oxygen changes everything there. Without enrichment, your flame temperature is around 1900 degrees centigrade and raft is thick, sluggish like cold honey. So add oxygen and that flame jumps to 2200 degrees centigrade. So the coke burns faster, the raceway deepens, and the raft becomes thinner and more permeable. So look at the two drawing. Left side, no enrichment, thick raft, poor gas flow. Right side, enrich, stable, open raft. So you are not just burning more coke, you are controlling the raft. And when you control the raft, you control the furnace. So let me show you how. So as you can see how it is getting controlled. So as you can see, these three graphs is shown, the three levers. Read them like your instrument. Graph 1 is oxygen percentage versus flame temperature. Every 1% increase in blast oxygen raises flame temperature by roughly 40 to 50. So at 21% oxygen, flame temperature 1900. At 28% oxygen, you are at 20 to 50. So that is the difference between a lazy raceway and a strong raceway. So graph 2 is about oxygen percentage, about oxygen percentage and raft thickness. So as flame temperature rises, raft gets thinner because the coke windows stay open and the softening ore melt more cleanly. But carefully, too much oxygen and the raft become too thin, then gas rushes through without good contact. So you lose CO utilization. So graph 3, oxygen percent is a permeability factor. See the sweet spot between 25 to 29%. Oxygen permeability is optional, pressure drop low, descent smooth. Below 24%, raft too thick, pressure spike. Above 30%, raft get unstable channeling risk. So your job is to keep the furnace inside that window. That's where the raft is happy, and so is your shift. So the oxygen raft controller, as you can see, that daily operational lever. Now, how do we actually use oxygen enrichment to steer the raft? So you don't just turn a dial, you combine it with the other levers. So these each operator have to learn. So this slide is your cookbook. Situation 1, pressure drop is rising and top gas CO2 is falling. So classic sign, raft is thickening, gas cannot get through. Action, increasing oxygen enrichment by 0.5% to 1%, but also reduce blast moisture by 1 gram per normal meter cube. That raises the flame temperature further. Then wait 30 minutes, you will see pressure drop comes down. Situation 2, silicon is above 0.7% and hot metal is cold. That's a raft that's too thick and too cold. Increase oxygen by 0.5% and simultaneously add a thin layer of nut coke. On the next charge, you will see the silicon drop within 2 hours. Situation 3, you want to ramp up the productivity by 5% for the rest of the shift. Increase oxygen by 1%, but you must increase coke rate by 2% to keep the raft from becoming too thin. Always rebalance the carbon. See the flow chart at the bottom. If pressure drop more than 1.5 bar and top gas CO2 less than 19%, increase oxygen. If flame temperature more than 20 to 50, decrease oxygen or increase moisture. You are the pilot. These all controls within you, and you have to control them. Only you can drive the plane type of furnace. So coming to the troubleshooting with the raft oxygen enrichment. So let me give you a real causes from my own ship. So these are not theory, they accept campaign. So case 1, hanging furnace. So body stop moving, pressure goes through the roof, the raft is too thick, it's stuck. We increase oxygen by 2% over 40 and 40 minutes, not all at once. So stepwise, the flame temperature hits 2280, burned through the choke point and the body drop. The crew cheered, but then we reduce oxygen back by 1%. So we didn't overdo it. Case 2, silicon rising to 0.85 and hot metal temperature falling. Every young operator want to add coke. Wrong. The raft is thick and cold. We increase oxygen from 26 to 27 and cut moisture from 12 to 9. So in 1 hour, flame temperature went from 2120 to 2230. Silicon dropped to zero point 0.5. Case 3, flooding. Liquid iron and slag leaking too fast. Heart not holding, that means raft is too thin. The gas is blowing right through. We reduce oxygen by 0.8% and increase moisture by 2 gram. Raft softened just enough to slow the trip. So problem solved in 45 minutes. Remember the warning sign on this slide. Flame temperature above 2250. Stop increasing oxygen. Raceway camera showing excessive brightness. Back off. Permeability factor dropping below 0.42. Increase oxygen. These are your basically guidelines which is to be followed without much delay. So coming to the daily raft oxygen enrichment part, where uh, we can our last slide, and this goes on your control room vault and the raft oxygen scoreboard. As you can see, there's basically five things. Every ship gauge one current oxygen enrichment percentage trained over last 4 hours. Is it drifting? Write it down. Guess two. To air flame temperature. If you don't have a pyrometer, calculate flame temperature. 1450 plus 8.5 into oxygen percent minus 21. So target 2100 to 2200. So below 2100, raft thickens. Above 2250, risk of raft blow through. So gauge 3 is permeability factor formula, blast pressure minus top pressure divided by blast volume. So target 0.42 to 0.48. If this permeability factor jumps above 0.48 after an oxygen increase, you have overdone it. So back of 0.3% oxygen. Gauge 4 is the raft position index, estimate from the shaft thermocouple. If 800 degrees centigrade isotherm moves up more than 1.5 meter in 2 hours, your CO2 is lifting the raft too high. Add a layer of center to push it down. So gauge 5, top gas efficiency, CO2 divided by CO plus CO2 should be 0.48 to 0.52. If it falls after oxygen increase, your raft is too thin. Reduce oxygen by 0.5%. Every morning mark green, yellow, red. Green, go. Yellow, have a plan. Red, call me immediately. This scoreboard turned oxygen management from a blind guess into a precision tool. You will produce more iron with a less coke and fewer problems. Any operator who uses this scorecard for 1 week will never want to run a furnace without it. So now let's go look at today data and tune that raft.